Okay, now let's talk about the ISDN channels. We have, ISDN actually, there's a digital pipe, we said, and this digital pipe is divided into a lot of channels, and these channels are of different size. Now, first is the B channel. This is the main channel because it's called B channel because it's a bearer channel, and it has some 64 kilobits per second of data rate. So it's a basic user channel. It takes full duplex mode of transmission, and it can carry data, voice, and some low data rate information. Okay, not like video. Okay, and we may have this B channel can have its connections. It can be purely circuit switched, so you can put a call uh, and circuit switching is being done. But there could be also the packet switch. Okay, so user may be connected via packet switching mode, and the data are exchanged with other users, using the X.25. And X.25 is basically, and it is an ITUT standard protocol suite for packet switches WAN communication. So you can communicate using the X.25. You have packet switching, or alternatively, you have the frame mode. In X.25, we have, this is also, X.25 is the protocol suite for packet switching for WAN, and frame is also a standardized, WAN technology that basically specifies the physical and logical layer of digital communication channel using a packet switching methodology. But there is a difference between X.25 and frame mode. A lot of things. It works in terms of packets, while frame mode, no, frame relays, we call them the frame relays. What I'm talking about, frame relay works in the frames. Basically, here we do a lot of error checking and control and all that, but here we want a speed. If we know the channel is less error prone, we can go for frame relays, and don't need to go for the error checking. Just dump in quickly the data and just get the speed out. Okay, this is basically 2 layers and basically 3 layers, and there's a lot to be discussed about X.25 versus frame relays, but I'm just talking about this here, that we can put the data in the ISDN channels, either packet switching mode or circuit switching mode, either frame mode in a frame relay. There's basically a logical link control, a special protocol called LAPF. There was link access protocol frame mode service. This is link access protocol frame mode service. So you can use in a frame mode LAPF. You can use X.25. Okay, or you may have semi-permanent where you can have lasered lines. You don't need even to do for switching. You can go for a lasered line. Then there is another channel called a D channel. Basically, D channel doesn't take the data, but it takes the control. Is the control channels goes on the D channel. You getting me? So control signals for bearer channel goes on a D channel. So it's around 16 to this D channel is around 16, or maybe some 64 kbps. It needs what the user needs, so it depends upon that. If now we can have in-band signaling and out-of-band signaling. If you have in-band signaling, then what we do is we combine the D channel and B channel, basically, because data and the control can be taken up by the single same cable. In the outer band, two different cables carry data and control. So we may have totally different cables on a B channel, which carries B channel, that's data, which has a D channel, that is what our control. Then there is a hybrid, that's called H channel. Okay, so this is for the higher bit rate. Now there are some types of H channel. One is called HO. It has a data rate of 384 kilobits per second. We have H11 H0 H1 with data rate that's data rate after 1536 kilobits per second, and H12, okay, of H channel but of 12, that's 1920 kilobits per second. So if you want to send some video or some teleconferencing or some teleconferencing, then you need definitely the H channel, is the hybrid, which has a very high speed. But if you have like voice like that, where you don't have that much of need, okay, um, maybe digital voice or something like well, something which has a low data rate, then definitely you can go for the B channel, and the control for the B channel goes on the D channel. And if I have the in-band signaling, we send them B channel and D channel on a same cable. But if we have the out-of-band signaling, then we need two different cables for B channel and D channel. For B for the bearer, the data, and the D for the control. Here, you getting me? Okay, that's all for these channels of ISDN.